See where it says auto high temperature? And now move your cursor away from it. Alright, so technologically there's going to be, we talked about this, there's going to be learning curves, okay? I've been using this program for 12 years. Okay? I've been using GeoGebra for 5-6 years. I know this stuff a little bit better than you guys do, so just bear with me when I'm trying to show you something or I do something. If you can watch it and then mimic it, eventually you'll learn that skill, okay? But if you're not paying attention, we're going to have trouble. There are some things, though, mathematically that we have to talk about in regards to constructions, okay? Because a human is doing them, okay? Because we're going to physically grab that compass and slide it and place it somewhere and start moving it around. There is going to be human error, okay? It's something that we can't avoid. We can do things to minimize it, but we can't avoid it. When we use GeoGebra, there's no human error. Okay, everything is precise, exact, accurate measurements, that kind of stuff. What I mean with human error in this regard, I'm zoomed out pretty far right now. I move my compass. My first step here will be move my compass to B, and it looks like I got my compass on B right now, right? When I zoom in, see how far off my compass is from B? Okay, and if I zoom in even further, okay, maybe you can see that that's a little bit worse, right? There's human error there. Okay, I might be off just a fraction of a millimeter. Okay, maybe I need B. Maybe I need my point to be right there. I might be off just a fraction of a millimeter. Even the thicker my lines are, the more human error is created. Okay, it's unavoidable. Okay, but we want to try to minimize it. So when we're done, we do a copy kind of idea here in a little bit when we're done. If yours doesn't match up verbatim, it doesn't match up 100%, but it's close, it's probably due to human error. Is that right, everybody? Okay. Another reason why using the other technology platforms might be useful. Okay. So I'm going to zoom back out just because I think zooming out is going to be helpful to see every aspect of this construction. So I zoom out. We're constructing an angle congruent to angle ABC. Okay, so the first thing I need to do is draw some ray that's going to mimic either ray BC or ray BA. Is that all right, everybody? Doesn't matter which one you choose. I'm just going to, because it's horizontal, that's usually the easier thing to do is draw that one. But I'm going to draw down here some ray that's going to mimic BC. Okay, and we've used some of this notation. We've talked about it early on. I'm going to call this point B prime. That point right there, B prime. Okay. Why do I call it B prime? Because the one above it of the given the given angle that we're going to try to copy has a vertex of B, right? So now I know B and B prime should correspond to one another. They should match to one another. They should relate to, correlate to one another. All similar words, right? Okay. You might hear me say B and B prime are analogous, meaning they match up. Okay. That's important as we go through. I think if you're going to label stuff, try to use that prime notation. It's going to make things a little bit easier for us. Okay. All right. So that's the first step. Second step. Take your compass, put your needle on B, okay? If you want to try to minimize your human error as much as you can zoom in real fast, get it on there, where you think the best spot would be, maybe right there, and then zoom back out, okay? That's not necessary, but it will minimize your error. Then you're going to open your compass up, okay? And I'm going to say open your compass up to a reasonable distance. I think that's reasonable, okay? It's not the maximum span that my compass has, and it's not a minimal span that my compass has. Does that make sense? It's in the ballpark of halfway, okay? And I want to go just a little bit more than halfway a lot of times because the bigger my construction is, the more room I give myself, the less human error there's going to be, okay? And if I have to, think about this. If I have to deal with a circle like this, okay, that circle is kind of hard to see, right? Okay, very small. But the next kind of step is going to use those intersection points that circle created with that angle. Because they're so small, so close together to one another, there's going to be more human error. Okay? If I can spread it out a little bit, give myself a reasonable distance, okay, do that, now there's less human error. Okay? Is everybody okay seeing that? I can change that thickness, and that's something to think about as well. The thicker your line, like thicker that line is, okay, I'm going to have to use these intersection points. Well, if I put my compass right there, or maybe right, see how many different places I can maybe think about putting that compass as where that thick line intersects the skinny line, okay, or the thick arc. That's a problem. So we don't really want that. The thinner the lines we use, the better. I don't know if I told you yesterday, if I was using an actual physical compass, you know, when you start using a pencil, your lead starts to get dull and it gets a fatter and fatter line, right? I would want really, really thin lead, okay? A really, really sharp point, okay? 0.7 lead or 0.5 lead. 0.5 would be better, okay? If I'm using a mechanical pencil or something like that. So we do that. Is that okay with everybody? When those intersect, when those lines intersect, those lines in that arc intersect, I get these intersection points. Let's label them. Let's call this one D, and let's call that one E. Ultimately, call them anything you want to, but now that I've done that, with the compass size being the exact same, I'm going to come back down to B prime, and I'm going to draw a similar arc. Okay, I need the arc to intersect my ray that I have, so I need that one. Does that make sense? Because that intersection point, you guys think about what we could call that one. What do you think we'd call that intersection point right there? D prime. Okay, that point right there corresponds to D. All right, I need to make this arc long enough so that we have E on there somewhere. Would you guys agree that E prime should be somewhere on that red arc that I just drew? Okay? Because here's E, right? E was, E was right there. So down here somewhere, E is probably going to be in that ballpark right there, right? Does that make sense? Okay. We're going to have a step here that actually locates it exactly. Okay? And it's by using our compass at D. We put our needle at D. And I'm going to zoom in a little bit to do this. You don't have to, but it'll help. I'm going to put my needle at D. And I'm going to adjust my compass. You might have to squeeze your compass a little bit and rotate a couple different times so that you can get that point of your marker to go through E. And I'm going to draw that arc. And that arc right there is just kind of a quality control thing to make sure that E is somewhere on that red arc that I just made. Does that make sense? I know E is now on that black arc, and I know E is on the red arc. So if I come back down to the picture that we had at the bottom, with the same exact compass, come straight down here, put my needle on D prime, okay, and then make a similar arc. Does that look like the red arc that we just made up top? Okay, so up top at E, we had a black arc, a red arc, and a ray going through it, right? Going through the same point. We say when those three things are all intersecting the same point, we say they're concurrent. That's the word we use. Concurrent just means that they're happening at the same time or same spot, same location. If we look at the bottom so far, we have the two arcs passing through that point. So what do we need to add? We need to add our ray, correct? Okay. So this point right here
That point right there is going to be E prime. And to get our ray, we take our straight edge. In this case, we're going to take our line tool. We'll put at B prime, and then we'll go through E prime. And now that angle is a direct copy of what we started with. We now have two congruent angles. Is that all right? Okay. Somebody in the last class, I did this in the last class, is I made that ray long, and I made this one real long, and their argument was, well, those two angles aren't congruent because that bottom one is so much longer or bigger, right? It's not the size of the rays that we're interested in. It's the size of the angle. It's the measurement or the degree of the angle. Okay. All right. So here's a way that we can check this. I'm going to select all this stuff. So just selecting like you would maybe in PowerPoint. You guys have some familiarity with PowerPoint, right? Okay. Or other Word documents, that kind of stuff. Maybe Publisher. I'm going to select those, and I can group those. I can hit Control-G, and it will group them. And now I can slide that up. And do we have that idea of congruency? Okay. Now, some of yours might be off a little bit. Some of yours might look kind of like that, where there's, if I zoom in, there's a little gap between our lines, right? Okay. Or maybe some of yours might, let me pull that down. They might overlap. I'll do it with a dotted line here. That one might overlap, but this one might be like that. Anybody want to talk about what that reason would be? Why there's a discrepancy there and they're not exact? Human error. Okay? But they should be in the ballpark or another. They should not be like that, right? Okay? That'd be a huge issue and you've done something wrong. You done a step wrong. Okay? So there will be human error, but if we can, the more things we can make the picture bigger, zoom in, that kind of thing, will minimize it. Yes?
How do you group them together?
Once you select them with your arrow tool or whatever, and your cursor. So I got that. So I'll click and drag. And then when you click or drag over everything that you want, just hit Control and G. And that should group them as well. And then if I want to ungroup them, I hit Control G again, and it'll ungroup them. And those are little things, guys, like grouping things and that kind of stuff. That's not part of this course. I'm not going to test you or quiz you over that kind of stuff. Those are kind of the intricacies, the ins and outs of these programs that maybe you're not accustomed to or something like that, but it's not going to impact your understanding of this stuff. All right, so let's talk about what this would look like in GeoGebra. Because in GeoGebra, because there is absolutely no human aspect, I'm not grabbing a compass and moving around. I'm not trying to put a needle on a point or anything like that. There should not be any human error. Okay. The only human error that occurs is if I mess up. Okay. If I do a step wrong, right? So I'm going to open GeoGebra and we're going to do this. Okay. So doesn't really matter what angle you start with. I'm going to choose my line tool here. I'm going to go down to segment. And I'm just going to create a segment and then another segment. Then it might make sense. I got rid of my grid. If you want to put your grid back in, that's fine. It might make sense just because of the way we've done it already to maybe allow your angle to be or have one side that's kind of parallel to the edge of your paper or the base of your screen or something like that. Is that all right with everyone? But this should work regardless of where the angle is. It could be like that, and I should be able to do the same exact steps and develop a congruent angle. Okay? So I'm going to start with that. If your person is anybody's not showing up their letters A, B, and C when they do this? Okay. If you're not getting A, B, and C to show up, you're labeling. Kind of it's the longer way, but it's the most simple way of getting that to happen. Is you put your cursor on top of the point,
or whatever your object may be. It might be a segment at some point or a circle that we want to label. And I right click and it should give me my drop down window. And these are all the different things I can do with that point. We want to show the label. Right now mine is showing, so if I click that again, it's going to hide it. But if it's being hidden right now and I right click and go down to show label, it should show it. And then you can do that for every single point that is hiding. Okay, and that's fine, but it's, so you're saying it's stuck to it, can't move it? Is that what you're saying? Let's just start over. It's because when you made it, you were stuck to the origin, and just for some reason the origin. Does that work? So if you ever, her issue was that she was like stuck to the origin. She put an angle here where one of her points was the origin and one of the points was on the axis. If I put a point on the axis like this, and I want to move it, I can move it in and out, left and right, but I can't move it up and down. It's stuck to it. It's attached to it. Same thing with the point here at D. I can't move. I grab it and I start moving my cursor. I can't move it. When you're stuck to the origin, you're stuck to the origin. All right. There are a couple tools that allow you to undo that, but the easiest thing is just to restart somewhere else away from those locations. All right. So we've got our angle here. We're going to try to copy it. Okay. First step. Draw a ray that's going to be one of your sides, either the ray for BC or the ray for BA. Doesn't matter. Staying kind of comparable to what we've already done by hand, I'm just going to draw a ray that would compare maybe to BC. Okay. I'm going to rename point D. So if I want to rename anything, I just again right click on the object that I want to rename, go down to rename. And I'm going to call this B prime. If I want to rename E, I don't really need to rename E. And it doesn't really even compare to C, I don't think, because it's not the same spot or same distance away from B prime. But if I want to name C prime, I can do that. Okay, so rename things how you see fit. Okay? You can if you want. So now we're going to put a circle around B. We'll put a circle around B. So, a couple ways of doing this. Let's develop maybe a little bit more fluency with the things, the options that we have in here. Let's take a point. Okay, just come to point, and then go down to BC, your segment BC, where your cursor turns into a hand, and just click. All right, and what we've just done is highlighted a point that is on BC, and you can move that, but try to move it up and down. It shouldn't be able to be moved off that graph or off that segment. Does that make sense? I can move it left and right. Okay, move it all the way to B, move it all the way to C, but I cannot move it up and down. All right, so here's what I want to do. Once we've done that, I want to go up to circle with center through point. This is a different tool than we've used previously. Click on that. And now what this does is I click on B, or my center that I want to use, and then I can move it by changing the radius by moving my cursor, right? Well, let's make it go through D. So click on D again. And now it defines that circle, but that circle, I can make it adjust, right? So this is maybe the infinite number of, we talked at the beginning, we didn't want to make a circle that big, right? When we did it by hand. And I don't want to make a circle extremely big. The way I've done this here kind of limits it, but somewhere in the middle. Okay, so that's probably a pretty good circle to create. Is that okay? What would be the radius right now? What would be a way of you telling me what the radius of that circle is? Any ideas? Radius of that red circle? BD. Good. Okay. The radius of that circle is BD. That's a distance, right? That's the way we talk about it. If I just say BD, that's a distance. Okay, I don't know what number it is, but that's how we represent it. That's how we talk about it. So when I draw a circle around B prime, I want to use the exact same radius. Okay. So I'm going to click on my circle tools,
And that second one that we've used for a while now is going to allow me to do that. Remember, that's a circle with a center and a radius. So I get to choose the center I want. I put my compass on B prime. And now I get to tell it what radius I want to use. So I want to use radius BD. And it puts that circle in. Okay. If you've got some stuff overlapping, that's fine, guys. You can move things around. Say that mine was like this. It was overlapping, and I don't want that to overlap like that. Does that make sense? Move B. Or B prime. Okay. Zoom out a little bit. You can zoom out and then move things around. Okay. I think maybe your best way right now, if you don't have a mouse to zoom in and out, is to click over here, choose these options, and then it gives you that cursor. But if you've got a mouse, the scroll on your mouse will allow you to zoom in and out real quick. So that step, guys, all that step is, you don't do this, just watch. That step was comparable to us doing this with the compass. That's all that step did for us. And you remember doing that by hand? Compass? Okay. So now we've got to find out, ultimately, this intersection point right here. We've got to find that thing. Okay. So if you remember doing that by hand, we needed to first locate that intersection point. So with this intersect tool, guys, you don't have to click on, here it says select intersection or two objects successively. I'm going to use that first one, select the intersection. I think the intersection is right there, right? Click on it. It will give me that intersection. I need this one over here as well, so I'll click on that one. Any time that we create a circle through some other shape, whether it be another circle, a line, a red, or whatever, I'm going to need those intersection points. So we have to identify them. We have to be able to get GeoGebra to put them and define them in there for us, so that we can recall them and use them in the next steps. Okay, so we have to do that. If I want to rename them, that's fine. This point here is going to correspond to what point over here? Yeah, F is going to be, I'm going to rename that to D prime. I think that makes a little bit more sense. Is that okay with everyone? So now we got to find E prime. All right, if you remember doing that, we took our compass, put our needle right here, right? Put our lead through E. Well, if I did that, okay, that basically creates a circle with a radius of D to E, doesn't it? Okay, so I'm going to click on my circle, the second option again, click on my circle to start at D, and I want to go through E. So D to E would be my radius, and it should give me that circle. I'm going to just make it dotted. Let me talk about it a little bit better. In that circle, guys, that circle right there is the circle that created that little red arc right there. Okay? I need to redo that down here. So I click on my circle tool again, click on D prime, and again I want the radius to be the same as the radius for this circle up here. This dotted circle had a radius of DE, right? So I type in DE. And hit OK. Okay. Do those two circles over here, do they intersect? Yep. So I'm going to fix that intersection point, see what it is. I call it F. I'm going to rename it, call it E prime. How many points do you need for a line, ray, or segment? You need two, right? Is B prime a point? Is E prime a point? And I connect them. And there we've got that construction developed. Now, this is the benefit of doing this type of stuff in GeoGebra. At no time did I worry about a distance, right? Worry about any numbers up there, right? Never talked about a number, okay? The only number we talked about was when Mike told me BD, And that really wasn't a number, right? It was just representative of some number. Okay? So, why I like GeoGebra is I can click this angle tool, and I click on D, B, A, and then D prime, B prime, E prime. And what do you recognize then about those two angle measurements? They're absolutely the same. No matter what your angle was, you could start with an angle that looked like that. You see that the two angles are the same, right? Okay? Never focusing on trying to get that to develop, never worrying about what the numbers were, we get congruency there. Okay? No human error, right? I could take, I don't know if I can move all these at once. I believe if I do this, I can. You know, they're going to match up just like we did with Smart Notebook, right? Okay, but there's no human error there because there was never a measurement or a drawing aspect that I had to do by hand. Okay, is that cool with everybody? Now it's messier looking, right? If I gave you an option of which one you want to look at, you would probably want to look at that one. That's a lot less congested. But the benefit of this, how many times does this red circle and this dotted circle intersect? They intersect here at E prime, right? Is there anywhere else? Intersect down there at G? What if I did this? You don't have to do this, but what if we took B prime to G? And then I ask it for, oh, wrong direction. Ask it for that angle. What's that angle turn out to be? 48.05. What does that make that red ray, if I made it a ray, what would that make that be in regards to maybe that blue angle? A bisector. Makes it an angle bisector. Okay? Guess what the next construction is? An angle bisector. And there are components to this that are going to be useful in that. Okay? Ultimately what happens here, guys, is in the next construction, the first step in the next construction, we'll start with the blue one. We'll start with the blue angle. Okay? And we're going to have to first draw in that red circle. It could be any red circle that we want it to be. Okay? And then there's going to be one step that allows us to go from essentially that red circle. Okay? It's going to create that intersection point at G and that intersection point at E prime, right? If I draw a circle centered at E prime, can you imagine that there would be one that goes through E prime to C prime? Is there a circle that will do that? Is there a circle that goes from G to C prime? The intersection of those two circles will create C prime for us. Alright? And then we'll have our angle bisector. It's really straightforward, really easy construction, but it's because of this one that maybe allows us to realize that. Another aspect of this is when we do this construction of angles, guys, it doesn't matter the orientation. Okay? This first angle could have been like that, right? Okay? Now, it disappeared down to the bottom right. Do anybody know why it's disappearing down to the bottom right? Yeah, so that's that red circle is ultimately not intersecting the dotted circle, right? I'm running out of, or I guess it's not intersecting my initial ray. So there will be times when you're moving things around because basically you're changing the size of your compass overall. You might end up with things disappearing, your construction failing, but it's because maybe you're violating the idea that we had to have a certain compass size or something like that. But this tells me that I can draw my angle above the ray that I set out with at the onset, or I can draw it below the ray, correct? Okay. You could have even started with, I could have started with a ray like that and gone through the construction and got the congruent one attached to that somehow. Okay. So just because they show up as a horizontal line
A lot of times, like we did here with B prime to D prime, they don't have to be. Okay, that thing could, when you're done, it could look like that. They're still congruent. Okay, it just might take a rotation for you to see if they do overlap. Okay, if you're to cut and paste them. All right, so let's do this one. Let's do a construction of an angle bisector. This is easy. This is probably the quickest one we've done so far. Maybe as quick as finding a midpoint. And you can zoom in on this one a little bit more. If you go to 100, I think you could be okay. You might even be able to go to 150 and be fine. Yeah, 150 will be okay. All right, so what we want to do is we want to put our compass first on our vertex of the angle that we're trying to bisect. We're then going to open our angle up, or open our compass up. Okay, now for the same reasons, we don't want a really small angle. We probably don't want a really big, I say angle, we don't want a really small circle or a really big circle. Something reasonable, something maybe 3/4 of the way, 3/4 of the span of my compass or something like that. And then we're going to draw an arc. Let's call those points X and Y. All right, so that arc, guys, that is the same circle that I talked about down here when we zoomed in on this angle bisector. It's that red circle. Okay, in that construction. It's the same one right here. Now what we're going to do, we need to find, we already have one point for our angle bisector. What is the one point that we know we have to use for our angle bisector? We have to use B, right? We have to use the vertex of the angle for our angle bisector. So we need to find another point somewhere that we can connect our straight edge with so it creates our angle bisector. And there's actually two other points that's going to happen. That we have choice of. But the easiest one is to find out here. The most logical one would be to find out here, right? You visualize there's going to be a point out here somewhere that I can connect B with that would create my angle bisector. But once I create this first circle, keep your compass the same distance, same circle, same radius. Put your needle on Y, that first intersection point, and draw an arc on the inside of your angle, and make it large enough and in a spot where you think your angle bisector is probably going to be passing through. Okay. I'm then going to go to X, put my needle on X with the exact same circle, and draw another arc. Okay? Now here's the idea. I don't want to just draw that part of the arc because it doesn't intersect the first one, right? I want to make sure that I'm drawing portions of the circles that are big enough to yield intersection points. Okay? Or to produce these intersection points. So that's what I need to do there. How many points do you need for a line, a ray, or a segment? You need 2. I'm going to click on B. I'm going to put my straight edge on B. Put my straight edge through that intersection point of those 2 blue arcs. And that dotted line then is a angle bisector. Okay? As you're doing these things, as you're doing angle bisectors, the key here is that once you set your compass to that first circle, either use that same size or something bigger. Okay? So for instance, if I were to use something bigger, okay, so let's go to Y, and let's say I make my compass larger than the first circle that I started with. And let me change my color, go red. If I make that arc there, and come to X, this is the problem with being zoomed in. Go to X, make that red arc. Would that point right there, along with B, produce the same dotted line? Yeah, okay? And I can keep making my compass get bigger and bigger. The only issue is that if I were to make it smaller, and I go to Y, and I make my arc. And then I come up to X and make my arc. What's the problem? The arcs don't intersect. Okay, so I had to keep my my compass the same or make it bigger. You could actually adjust it so it's a little bit smaller, but at some point you don't know where, those two circles that are being created are going to separate from one another. They're not going to touch. Okay, and there's an issue with that. Is that okay? We can do the same thing. Skip over maybe the GeoGebra construction of this with you directly. Let me just do it real quick for you so we do have it on video maybe. But we can create an angle, right? Okay. And when we create that angle, the first thing was to draw a circle that went around A, and it just had to intersect your two rays, right? And then we had to construct the same size circle around B and D, right? Okay. What's the radius of the circle that I have up there right now? AB. Is there another way of naming it? AD, okay? So I'm going to choose that circle, locate at B, and I'm going to say the radius has to be AB. I'm going to do the same thing at D, radius has to be AB. And it gets sloppy right away, right? Okay, it gets real messy to look at, but I'm looking for that intersection point. That little portion right there, and that little box. Those are the two arcs that we were drawing by hand. Okay? I can then go from A to E, and that blue ray then is my angle bisector. Why is it beneficial to maybe be able to do this right now in GeoGebra and maybe do it later in other aspects? Is because I can get rid of the components. The only way I can get rid of components by hand is to grab my eraser and erase them, and they're no longer there, right? But with GeoGebra, I can hide them and then re-show them, and then hide them again and re-show them if I need to. But when they're hidden, it's not like I've erased them. Does that make sense? I haven't deleted them. They're still there in the background, serving their purpose. Okay? But here I can now click on that. See how if you ever click on the angles and you get something like that, you get the wrong angle? It's because of the order that you click the points. So I'm just going to hit Control-Z and flip my order. Control-Z undoes it. Flip my order, E to A to B. And what do we see there? What's the relationship between those two things? They're the same. But why is GeoGebra useful? As I move it, that construction in the background, those circles in the background are changing, their intersections are changing, and they're forcing that angle bisector to be consistent, right? Okay. So that's something that we'll use a lot to kind of understand other concepts down the road. In your homework, okay, in the end of course exam, they might ask you something like, give me the steps, because this won't be a construction other than today that we talked about, but give me the steps to create an angle that is exactly 45 degrees. And we haven't ever talked about it. And you might be presented with a question like this later on where we never talk about it, but we have the foundational constructions to do it. Okay? Yesterday or the day before, I guess, we found a midpoint, didn't we? Okay, if you remember finding a midpoint, we started with a segment. We made our compass a little bit bigger than half. We drew that arc. We then went to the other endpoint. Did the exact same thing, right? And then I connect those intersection points, and what do I create? A midpoint, right? The intersection of those things is a bisector, and it creates the midpoint. What else does it do for us, though? It was what kind of bisector? Not just a bisector, but was a perpendicular bisector. What's perpendicular mean? Form 90 degrees. Form right angles. Okay? So that blue line, or blue ray segment, whatever you want to use,
is a perpendicular bisector of the black one. So the perpendicular bisector, you say, gave me right angles. Right angles are how many degrees? 90. What can you do to a 90 degree angle so that turns into 45? Or did you create 45? You bisect it. So on top of this, and you guys don't have to do this, but you can see that if I were to take, let's change my color to, let's use this purple one. If I draw that arc, okay, and then come here, draw that arc, go here, draw that arc, make sure those arcs intersect, and they're doing a great job here, but they do intersect there. And now, from here through those, did I bisect that right angle up in the top right corner? Okay, so now I know I've got 45 degree angle. What if I ask you to create a 22.5 degree angle? Do the exact same thing, right? With one of those 45 degrees. And I can keep doing that, right? All right. So those might be little questions that they ask you that we never directly focus on, but you can piece together and think about the constructions we've done and stack them on top of one another to create something new that you know to be true the way you do that. Is that all right, everybody? The 1.6 assignment still open. It's going to be due tomorrow. Make sure to finish that before class tomorrow.